Hello, I'm Danielle Augustine, and today I will be presenting my Intro to Geophysics final project. I decided to do electrical resistivity on residential areas that have an infestation of chipmunks. Chipmunks tend to burrow underground in gardens or other types of property that can cause damage to people's gardens or lawns. And so the identification of these burrows can be beneficial to homeowners who would like to remove the population of chipmunks, whether that be by calling wildlife control or some kind of animal service to relocate the population of chipmunks, or to use a more extreme approach of extermination of the population of chipmunks. So my hypothesis was, quote, by using an electrical resistivity survey, the general size, depth, and locations of chipmunk burrows can be determined through interpretations of the resistivity data. Chipmunk burrows can be identified in areas of high resistivity. The equipment I used was the SuperSting R8 main processor, a switch box, a Windows computer that was borrowed from the geology department at NKU, a battery, 14 electrodes, 2 cables, and a tape measure. So the area of the procedure was we first identified the area that we would like to test for the burrows. We chose an area that we could see on the surface, as you can see kind of right here on the second picture. Barely in the image, but in person it's a lot more obvious that there are holes where chipmunks have been buried or like digging into the ground. So we identified the area we wanted to test, and that was down this hill. I think we decided to choose this area because it was perpendicular to the way, so the chipmunk holes were here, and we wanted to go across them. We used the tape measure to measure from the top of the hill to the bottom, and we put an electrode at each meter. So every electrode was 1 meter apart. We then uncoiled all of the cables and attached the electrodes to the attachments, making sure that no electrode was skipped or there were no twists and tangles in the cord. We wanted to have a nice organization of our equipment. We attached the cable to the switch box, and then we decided to set up the SuperSting, the computer, and open up the programs and get all of that settled. Then we connected the SuperSting to the switch box. And finally, the last thing we did was set up the battery. When we set up the battery, we made sure that we very carefully attached the positive to the positive and a negative to the negative, so we did not fry the battery. And then we attached the battery to the SuperSting. So the results that we got, we have the raw data on the top and the inverted data on the bottom. The areas in blue show high resistivity, so those could be potential areas of chipmunk burrows. And you can see them right here. And like I showed in the previous picture, which you'll see soon, the chipmunk burrows can be identified from the top of the surface, and they will be hypothesized to continue under electrodes or under and between electrodes 8 and 10. These holes are about 1.2 meters away from the electrodes. So in conclusion, the electrical resistivity can be used to identify empty holes, burrows, drainage, or other types of underground passages, which can be used for multiple other purposes, not just finding chipmunk burrows. And if the experiment were to be ran again, I would decide to do a second test of a line of electrodes going perpendicular to the original line over top of the chipmunk holes, you can see like this. So I would probably go, let's see if I can draw on here, this way across to see the true extent of the chipmunk burrows underground, not just very basic 2D identification. So this would make it a more third-dimensional type of mapping that we could do with the chipmunks underground. How do I get this? And I apologize. can't seem to get out of my annotation. Okay, so conclusion, like I was saying, the electrical resistivity can be used for other empty holes and burrows and drainages. And again, if I were to run the experiment again, I would do it perpendicular to the original line over top of the chipmunk holes that are seen on the surface. And I decided to do a little reflection. So I understand that this was not the most financially practical use of geophysical tools that could be used to identify holes underground. A cheaper approach could be GPR, or ground penetrating radar. I decided to go with resistivity because I wanted to get more hands-on practice with the equipment, so that in the future, if I'm ever in the field or working for a geophysical company, I have a good base understanding of how to use all of the equipment, from setting up the electrodes to working and putting the supersting together and looking at the data, and also using the program. So that is why I chose electrical resistivity. Thank you.